Good afternoon. This is Krithika here. So I'm pursuing my MSc Chemistry from James College, and I have been into teaching from a couple of years. So today also I would like to teach, or we'll start revising the important chapters that are necessary for the 10th CBSE exams. So the lesson I will first start revising is the classification of elements. So during early ages, probably during 1800s or 1700s, a lot of elements were being discovered, and it was very necessary for us to study about these elements because a lot of elements were discovered during the process, and it was necessary for us to put a systematic way of studying these. So a lot of scientists came up with a lot of ideas, unique ideas as to how to group these or how to study these or how to put into certain groups or study these. So the first kind of scientist who came up with an idea was scientist named as Daubeney. So he proposed something called as the Daubeney triads during the year 1817. So according to him, what he did was he grouped the elements in terms of in groups of three, which are called as the triads. So according to Daubeney triads, what he stated or what he proposed was that the average of the atomic masses of the first and the third element is equal to the atomic mass of the second element or the middle element. Which means what? If you take the example of lithium, sodium and potassium, the average of the atomic masses of lithium, that is 6.9, plus the atomic mass of potassium, which is 39, will give you 22.9, which is approximately equal to the atomic mass of sodium. So the next kind of triads he could get from the elements was chlorine, bromine and iodine. Similarly, you had calcium, strontium and barium. When you take the average of the atomic masses of the first and the third element will give you the atomic mass of the second element. The major limitation or the drawback for this was that he could not arrange all of the elements that were known during that time in terms of the triads because they didn't satisfy his rule or whatever he proposed. So this was a major limitation. So the major thing that we need to know is that he arranged it in the increasing order of the atomic mass. You see here, lithium, sodium, potassium, 6.9, 23, 39. So if you observe here, all of his triads had increasing in atomic mass. So because of this limitation, people wouldn't or couldn't accept his proposal. So after Daubeney, scientist came as Newland. So what he did was, that was around the year 1866. So what he did was, he arranged the elements in terms of 8, in groups of 8. So you have 1, 2, 3, 4, 5, 6, 7, 8. So according to law of octaves, he introduced something called as law of octaves, and according to this, every 8th element showed similar properties or similar behavior as that of the first element, which he referred to as octaves. So during that time, the hydrogen was known, which had the least atomic mass, and thorium was the element which had the highest atomic mass. So between hydrogen and thorium, he arranged the elements in groups of 8, where every 8th element showed the similar properties as that of the first element. Again, he also considered the same concept as increasing the atomic mass. Now again, the major drawbacks of Newland's octave was that he assumed that there were only 56 elements existed in nature, but now we know that more than 100 have been discovered already. So that was a major drawback. The second drawback was that this law of octaves, it was applicable only till calcium. So after calcium, not all the elements, not every element, 8th element showed a similar property as out of the first element. So these were the major drawbacks of Newland's octave. So the next came up Mendeleev's periodic table. So after the failure of Newland's octave, there came a scientist named as Mendeleev, and he came up with something called as Mendeleev's periodic table. He arranged the elements in the form of a table and referred to as a Mendeleev's periodic table. So what he did was, he not only arranged the elements in terms of on the basis of atomic mass, but also arranged it on the basis of fundamental properties and chemical properties. So according to Mendeleev's periodic law, it states that properties of elements are periodic function of their atomic masses. So the Mendeleev's periodic table has vertical columns, which are called as groups, and horizontal rows, which were called as periods. So this was one of the major, you could say, kind of success rather than these new lengths octave and Doppler strands. So next came a better version of Mendeleev's periodic table, which is called as the modern periodic table, which was discovered by Henry Moseley in the year 1913. What he did was, this was actually taken to a next level. So he also arranged elements in a periodic table only, but the major difference is that he arranged them basis of atomic number and not the atomic masses. So all of the scientists before Moseley, they all arranged the elements in terms of increasing atomic masses, but he was the one who arranged them in the terms of atomic number. So the modern periodic law states that properties of elements are periodic function of their atomic number. So the only difference between the Mendeleev's periodic law and the modern periodic law is that atomic number and the atomic mass. So again, modern periodic table has vertical columns called as the groups and the horizontal rows called as periods. So there are 18 vertical columns and 7 horizontal rows. So this is what we use now to study anything and everything. So this is the basis for all of the chemistry elements that have been discovered. And he also was very clever enough. He left few places in the periodic table, knowing that there will be elements discovered in the future where they can just be plugged in according to the properties. So after knowing about all of this, it is very crucial for us to know some of the trends that are there in the periodic table. As we said, the periodic function, it is important for us to know the trends that happen in the periodic table. The first kind of trend we will be studying is the atomic size. Now, what do I mean by atomic size? So consider the nucleus. So I'll just write it here. I'll just erase this and I'll just explain it here. Now, what do I mean by atomic size? So you have the nucleus here, right? And you have your shells, correct? And you have the electrons filled here. Now, what does atomic size or atomic radius mean? That the distance from the center of the nucleus to the outermost shell is called as the radius, atomic radius or the atomic size. Now, what happens to the atomic size as we go down the group, as we go across the period? Now, to know this, we have to know the elements that the atomic number of the elements. That is considered hydrogen, helium. Hydrogen has atomic number 1, which means what? The nucleus is here, there is just 1 electron. Helium, atomic number is 2, so you have 2 electrons. Now, let's come to the second period. So, lithium is 3, so what will happen? You have nucleus and 1 electron, then you have 2 electrons. Then barium is 4. 1, 2, 3, 4. So what happens is, as you go across the period, if you see, the electrons are getting added to the same shell. So for example, see, lithium has 2 shells occupied, beryllium also has 2 shells occupied. You have boron, let us consider boron. Boron has 5 electrons. So 1, 2, 3, 4, 5. Let's come to carbon. Carbon has 6 electrons. So 1, 2, 3, 4, 5, 6. If you see here, across the period, what is happening here? The electrons are getting added to the same shell, which means what? The atomic radius or the atomic size is the same. So as you go across the period, the atomic size remains the same. Now let us see what happens when you come down the group. So you have down the group, the first group has hydrogen, lithium, sodium and potassium. As I said, hydrogen has just 1 electron in the outermost shell, right? Hydrogen. Next you have lithium. So lithium has 3. So this is the nucleus, 1, 2 and 3. Next, sodium. 1. Sodium's atomic number is 11. So 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Next, potassium. So what you see here, and you can continue, go on doing it. If you see here, the number of shells is increasing, which means what? The atomic size. What I said, atomic size is the distance from the center of the nucleus to the outermost shell. So what is happening here? The number of shells are increasing, which means what? The atomic size or the atomic radius is also increasing, which means what? the atomic size increases down the group. Next kind of trend that we will study is the metallic character. Now, what are metals in general? So metals are those which easily donate electrons, right? They are deficient of electrons, they need electrons. So they are the one which easily accept electrons. So to understand the metallic character, what happens to the trend, we'll have to know what the term effective nuclear charge means. Now what effective nuclear charge means is that, let me just draw the shells and just explain. So what does effective nuclear charge means? So suppose this nucleus, there's a nucleus here. Obviously, it is a nuclear force that holds the entire atom, right? So nuclear force is something which is holding all of the shells towards the cells, because of which there is the representation of the particular element. Now, obviously, when I say this nucleus will have more force on this than these electrons, which makes sense. Why? Because the distance between this nucleus and this electron is very less when compared to the distance between this electron and the nucleus. So what I'm trying to say here is effective nuclear charge is nothing but the amount of force that the nucleus will have on that particular electron. So higher the distance, lesser is the effective nuclear charge, right? Higher the distance, lesser will be the effective nuclear charge. Why? Because this will have easy, what you can say, it obviously have more force on this rather than this because of the distance. So what I can say is the metallic character increases down the group, whereas it decreases across the period. Why increases down the group? As I told you, the number of shells are increasing down the group, which means what? The effective nuclear charge will also decrease, which means what? For me to pull out the electron from the outermost shell will be very easy, because this electron will have less effective nuclear charge when compared to this. It's almost like you have your planet, solar system. So you have the sun, you have the Venus, Earth, Mars, Jupiter, and all of that. So you can similarly consider that like this. And when I say metallic character decreases down the group, why? Because the nuclear charge increases, which means what? For me to pull the electron from the outermost shell will be easy, which means what? The metallic character increases. What does metallic character increase mean? Which means that they will easily accept the electrons. So the metallic character increases down the group and decreases across the period. So these are the two important trends in the periodic table that we have to know. So this concludes the classification of elements chapter, and the crucial questions or the important questions they could ask is, what are double triads? They could ask, for example, limitations, and what is Mueller octaves, example and limitations, and the statement of your Mendeleev's periodic table, or they could also ask modern periodic table and the drawback of each. And this is very, very important. They'll definitely ask you what the trends in the periodic table and how they vary.